Welcome to Chanan Academy. In today's class, we are going to be discussing variation. Variation is a term that refers to the relationship between two or more quantity, such that a change in one quantity results to a change in the other. For example, if a book costs 20 naira, if you buy one, you're going to pay 20 naira. Now, if you decide to buy 3, the price of the book goes up. It becomes 60 naira. In this case, a change in the quantity you buy also affects a change in the costs of what you're going to pay. So that's what variation is talking about. And the symbol we use for variation is this. And this is the symbol. So this symbol indicates variation. Suppose you want to say, okay, the price of book being B and the cost. So you can say book is having a relationship with C, which is the variation. Now, there are 4 major types of variation. The first type of variation is known as the direct variation. The second type of variation is called the inverse variation. The third type of variation is known as the joint variation. And the fourth type of variation is called the partial variation. These are the 4 types of variation that we have. Now, let's talk about each of them. Direct variation. Now, 2 quantities are in a direct relationship if one of the quantity increase or decrease and it affects the other quantity in the same manner. Let's say we have 2 quantity A and quantity B. If quantity A increases, then quantity B also increases. And if quantity A decreases, quantity B also decreases. Now, this type of relationship where an increase in one quantity also affects the other quantity to increase is known as a direct relationship or a direct variation. So we can say, so now let's take an example. Suppose in a shop, a pen costs 50 naira. If you buy one of the pen, the cost is going to be 50 naira. Now, in this case, the more pen you buy, the more money you pay. So it means that an increase in the pen, the number of pen, also lead to an increase in the costs. This type of relationship is known as a direct relationship because if one of this quantity increases, the other also increases. An indirect relationship, the symbol can be given as, let's say the 2 quantity we have is X and Y. So if we want to represent this in a direct variation, we are going to say Y is directly proportional to X. So this is how it is represented. We say Y is directly proportional to X. Now, if we have that Y is directly proportional to X, now for us to change this sign to an equal to, we need to introduce a constant. And that constant is called constant of proportionality. So let's call the constant K. So it's going to be Y equal to K multiplied by X. Now take note, K is known as the constant of proportionality. So the K is known as the constant of proportionality. And from this case, if we decide to make the K the subject of formula, so we'll divide both sides by X. And when we do so, we are going to have K equal to Y over X. So this is the formula for direct variation. Alright, we are going to take some example so we can explain this much better. Alright, so the first example says that Y varies directly as the square of X if Y equal 98 when X is 7. Calculate Y when X equal 5. From the question, we already see that the variation is a direct variation. So we can say Y varies directly to the square of X, not just X, so the square of X. Now, for us to introduce equality sign like I earlier mentioned, it becomes Y equal to K X square. Introducing the K, That's the constant of proportionality. Now we are told that y is 98 and x is 7. So we have 98 equal to the k, then x is 7, so we can multiply by 7 square. Now then we have divide both sides by 7 square. We are going to have k equal to 98 divided by 7 square. K will be equal to 98 over, so 7 square is 49, so we have 49, and we divide that. 49 into this 1, 49 into 98, we have 2. So our k is equal to 2. Now look at the question. It said now we have that. So now we have that x is equal to 5. What is y? So let's do that here. Y is equal to k multiplied by the square of x. So y will be equal to, the constant is 2, multiply, x is 5, so 5 square. So y will be equal to 2 multiply 5 square is 25, and then y will be equal to 50. So our y is 50. Alright, so let's take another example. So the second question says, if x varies directly as y cubed, so it means x varies directly as y cubed, alright, and then x equal to when y is 1. Find x when y equal 5. So we know that for us to introduce the constant of proportionality, we have to make x equal to the constant multiplied by y cube, and if you make k the subject, becomes k equal to x divided by y cube. Now we are told that x is equal to 2 when y is equal to 1. So let's look for the constant. So the constant k will be equal to 2 over y cube. Now equal to, now 1 cube is still 1, so we have k equal to. Alright, so now the question is asking that find x when y is 5. So we are going to have that. Now y is equal 5, the k is equal to, now we are looking for x. So we have x equal k y cube. Therefore x will be equal to, k is 2 and y is 5, so multiply by 5 cube. X is then going to be equal to 2 multiply 5 cube is 125. Therefore our x will be equal to 250. So this is our x. Inverse variation. Now two quantities are in inverse variation if one increase while the other decrease. That is, if we have two quantities a and b, when a increases, b decreases, and if a decreases, b increases. So their relationship are inverse, and it can be represented as, if we say a is inversely related to b, we can put it in this format: a inverse b. Okay, now also for us to change this inverse symbol to equality sign, we introduce a constant k. So then we have a equal to k multiplied by 1 over b, which is the same thing as a equal to k over b. And then if we want to solve for k, the constant, which is equal to a multiplied by b, take note k is the constant of proportionality. Alright, so let's take an example to explain this. Now the question says, the length a person can jump is inversely proportional to his weight. If a 20 kg person jumps 1.5 meter, find the constant of proportionality. Alright, so we already know from the question that the relationship is inversely proportional. So then we can say, let's say the length of the person is L and then the weight is W. So the length is inversely proportional to W, so we have inverse proportional to W. Now having this, note length L is equal to length, and then W is equal to weight. Okay, now so if we are going to introduce the constant of proportionality, it's going to be equal to L equal to K over W. Now we're told that weight W is equal to 20 kg and then the length is equal to 1.5. So if we substitute that in the equation, we are going to have that 1.5 is equal to k over 20. Therefore, we're going to have that k is equal to 20 multiplied by 1.5, and k is equal to 30. So this is our answer. K is 30. Alright, let's take another example. Alright, so the second question says, if W varies inversely as that expression and is equal to 8 when U is 2 and V is 6, find a relationship between U, V, and W. Solution. We have that W is inversely proportional to U, V over U plus V. So let us introduce the constant of proportionality. So W is equal to K over UV over U plus V. Now, this entire expression is same thing as K divided by UV over U plus V. Now, if we change this division to multiplication sign, we are going to have K, and then we invert this fraction, it becomes U plus V over UV. So it is K multiplied by U plus V over UV. So then we have K in bracket U plus V all over UV. So therefore, our relationship becomes W equal to K U plus V all over UV. So from this point, we can solve for K. We're told that W is 8, so we have 8 equal to, we don't know what is K, open bracket, U is 2 plus, and then V is 6, so we have 6 all over 2 multiplied by 6. Now this is going to be 8 equal to K plus 8. 2 plus 6 is 8 all over 2 times 6 is 12, so we have 12. At this point we cross multiply, and then we have 8 multiplied by 12 equal to K 8. 8 multiplied by 12 is 98, so we have 98 equal to 8K. So from this point you can divide both sides by 8, so 8 into this one, 8 into this, we have 12, so we have 12 equal to 8181, so we have just K. So our K is 12. So now that we know that our K is 12, let's go back to the variation. W is equal to K open bracket U plus V all over UV. So the relationship now is going to be that since we already know that K is equal to 12, so we are going to introduce 12 there. We have that W is equal to 12 open bracket U plus V all over UV. So we cross multiply, we are going to have W U V equal to 12 U plus V. So these are the relationship. So in this case, this is the relationship. But however, if you decide to simplify it, then you have this as the relationship. So whichever one of them is correct. So that's the relationship between W, U, and V. Alright? Alright, so the third question says x varies inversely as the square root of y. If x is equal to 1 when y is equal to 1 over 4, find y when x is equal to 1 over 6. Alright, so let's solve that. So we are going to put it like this, that we have x1 and x1 is equal to 1. So we have y1 is equal to 1 over 4. So we have x2, x is 1 over 6, and then y2 is what we are asked to solve. Since the relationship between x and y is inverse, so we can represent it as x varies inversely as the square root of y. So this is the relationship, and then when we introduce the k, then we have x is equal to k over root y. So therefore k will be equal to x root y. Then we have k equal to, our x is 1, so, and then 1 over 4. Alright, now take note, this also can be expressed as 1 over 4 raised to the power 1 over 2. Then we are going to have that k is equal to 1 multiplied by 1 over 4, all in bracket 1 over 2. So k is equal to 1 multiply. If you open the bracket, you're going to have 1 raised to the power of half is 1. 4 raised to the power of half. Now take note also that 4 can be expressed as 2 times 2, which is equal to 2 raised to the power of 2. So, and then if you have 2 raised to the power of 2, open your bracket, 1 over 2. Then we are going to have 2 raised to the power of 2 over 2, because you are going to multiply this power according to the law of indices. Therefore, this is then going to give us 2, because 2 cancel out 2, then we have 1, so it's 2. So we can say that everything here is going to give us 2. Alright? So then we have k equal to 1 multiplied by 1 over 2. So k is equal to 1 over 2. Now we have been able to find k, which is the constant of proportionality. But we also told that x2 became 1 over 6. We are now to find y2. Alright, so x is equal to k over root y. Now our x is now 1 over 6. And we saw for k to be 1 over 2 all over the root of y. Now let's try to make y the subject of formula. So we're going to have root y equal to 1 over 2 over 1 over 6. Take note, this also can be expressed as 1 over 2 divided by 1 over 6, which is then equal to 1 over 2. Change this division sign to multiplication. Comes 6 over 1. 2 here, 1. 2 into 6, we have 3. So therefore, everything there is going to be 3. So we have that root y is equal to 3. Now remember, we're looking for y, not root y. So for us to be able to cancel out this root, we take the square of both sides. So to take the square of both sides, we have y root y square equal to 3 square. And then the square root to cancel out the square. Then we have y equal to 9. So our y is 9. So look at this question. Variable y is inversely proportional to x squared. When y equal 10, x equal 2. What is y when x equal 10? Alright, so please try this and drop your answer in the comment section. Joint variation. Joint variation involves more than 2 variables. It's a process whereby a variable varies with 2 or more variables. Now, for example, we have variable a varies directly as variable b, and also variable a varies directly as variable c. In this case, variable a varies directly as a and b, so we can say variable a varies directly as b and c. Now, joint variable can be direct, or it can be direct, inverse, or it can be inverse. Alright, so let's try to explain what I mean by that. So for direct, it means that a variable varies directly as 2 other variables, like this example I gave. Or so if a varies directly as b and c, so we can say a varies directly as b and c, which can then be expressed as a equal to, when we introduce the constant of proportionality, cons k b c. Now this is direct. So for direct, indirect, we can have that if a varies directly as b and then a varies inversely as c. Now from this we can have that a varies directly as b and inversely as c. And when we introduce the constant of proportionality, it can then be given as a equal to kb over c. And also for this third one, which is inverse, we can have that a varies inversely as b, and also a varies inversely as c. Then we can have, from this we can say a varies inversely as b and c when we combine it. Therefore we can introduce the constant of proportionality, then a is equal to k over bc. This is what joint variation means. Alright, so let's take some example to see how it works. Alright, look at this question. The question says p varies directly as the square of q and inversely as arrow. If p equal 36, when q equal 3 and arrow equal 4. Find p when q equal 5 and arrow equal 2. Alright, so let's solve that. So alright, so the first statement says p varies directly as the square of q. So it's going to be p varies directly as the square of q. So the square of q. So this is the first one. And inversely as arrow. Okay, so it's going to be p varies inversely as arrow. So these are the two variations. Okay, so let's join them together. If I join them together, it simply means that p varies directly as the square of q and then inversely as arrow. And when we introduce the constant of proportionality, we are going to have that p equal to k multiplied by q square all over arrow. So this is the relationship. Let's go back up. Let's look at the value for each of them. So p, let's call this p1. p1 was 36, q1 was 3, and then arrow 1 was 4. We're then given that q2 is equal to 5. That's the second q. And then the second arrow, which is arrow 2, is equal to 2. Alright, so we are asked to find p2. So let's substitute the value for each of them. So the p1 is 36. So we have 36 equal 3 square multiplied by k all over. So arrow 1 is 4. So we have 4. So when we cross multiply, we're going to have 36 multiplied by 4 equal to 3 square is 9. So we have 9k. So when we multiply the left hand side, we are going to have 144 equal to 9k. So the next is to divide both sides by 9. Okay, if we divide both sides by 9, we are going to have 144 over 9 equal to 9k over 9. 9 divide 9, 1. 9 divide 144, 16 times. 9 into 9, 1. 9 into 9, 1. So we are going to have that k is equal to 16. So this is our k. So it's time for us to solve for p2. Remember, the relationship still remains p equal to kq square all over arrow. Now that we have our k is equal to 16, so we can say it's equal to 16q r square all over arrow. Okay, so we don't know what is p. We are asked to look for p. So p is equal to 16 multiply our q2 is 5, so we have 5 square all over. So our r2 is 2, so we have 2. Now, so we have p equal to 16 multiplied by 25 all over 2. Then p will be equal to 16 multiplied by 25 is 400 over 2. And this is going to give us 200. So our p is 200. Alright, so let's take one more example. The weight of a metal bar varies jointly as its length and the square of the diameter. If the weight equal 140, the diameter equal 4 whole number 2 over 3, and the length equal 54, find the diameter in terms of the weight and the length. Alright, so pause this video, try to see if you can solve this question, and then play. Alright, so let's make assumption that weight is equal W, the length is equal L, and the diameter equal D. Okay, so from the question we were told that the weight W varies jointly, which means both variation are direct variation. Okay, so it varies jointly as the length, and then W varies also directly as the square of the diameter. So varies directly as the square of the diameter. Okay, so when we join this together, we are going to have W varies directly as the length and the square of the diameter. So let's introduce the constant of proportionality. It becomes W equal to K LD square. Okay, so let's try to solve for the constant. From the question, W is equal to 140, L is equal to 54, and then D is equal to 4 whole number 2 over 3. So we can have that W, which is 140, is equal to K multiplied by 54. Let's quickly convert this to an improper fraction. If we do that, we're going to have 14 over 3. So we have 14 over 3 square. This is then equal to 140 equal to K multiplied by 54. Now when you square everything inside, you're going to have 196 divided by 9. This is equal to 140 equal to k multiplied by 54 multiplied by 196 all over 9. From this point, we can cross multiply. When we cross multiply, we're going to have 140 multiplied by 9, which is equal to the k multiplied by 54 multiplied by 1. Now, from this point, we can divide both sides by this. So we don't have outrageous value when we multiply that. So we're going to have 140 multiplied by 9 all over 54 multiplied by 196 equal to k. When we multiply this, we are going to have 1260. We're going to have 10,584 equal to k. However, the simplest way you would have just done is to look for what can divide the numerator and also the denominator, so you don't have this outrageous number. But for the sake of simplicity, so we have to just bring out the outrageous number. Okay, so at this point, let's try to simplify the numerator and the denominator of the left hand side. Okay, so what can divide both ends? 252 can divide the numerator and also divide the denominator. If 252 divide 1260, we are going to have 5. And if 252 divide 10,584, we are going to have 42. So our k is equal to 5 over 42. However, from the question, we were told to find the diameter in terms of the weight and the length. So then we have W equal to KLD square. Okay, so now we know what is our k. So then we have k is equal to 5 over 42 multiplied by L multiplied by D square. So what the question actually means is to make D the subject of formula. So for us to do that, we have to make this D in place of W. Okay, so let's try to do that. This same thing can be written as W equal to 5LD square over 42, since everything is multiplication. So we can cross multiply. If we cross multiply, we are going to have 42W equal to 5LD square. For us to have D square at the right hand, we divide both sides by 5L. So we are going to have 42W all over 5L equal to D square. Okay, we are getting close. So we have D square, but however, we are not looking for D square, we are looking for D. So we'll take the square root of both sides. We have the square root of 42W over 5L equal to, so the square root to cancel out the square, so we have D. So this is our answer. Partial variation. A partial variation is a relationship that consists of two or more parts added together. For example, if we say A is a variable and it is partly constant, which is K, and also it partly varies as B, so A also varies as B. Now this can then be expressed as A equal to, introducing the constant, KB. Now for us to combine these two, we are going to have that A is equal to constant plus KB. So this is what a partial variation is talking about. All right, so let's take some example. The question says y varies partly as the square of x and partly as the inverse of the square root of x. Write down the expression for y if y equal 2 when x equal 1 and y equals 6 when x equal 4. All right, so take note of this statement, partly. Now, because it's a partial variation, we are not going to combine them together. We are going to add them together with an operation plus. So we are going to have that the first variation, y varies as the square of x. That's the first variation. And then the second is y varies inversely as the square root of x. All right, so let's try to introduce the constants into the both of them. So let's call this y equal, let's call this the constant 1, the first constant, x square, and then y equal to, this should be constant 2 over the root of x. So these two variations are going to be combined together with an operation plus. So we're going to have y equal to k1 x square plus k2 over the root of x. So this is what we are going to be using to solve. All right, so let's state the value for each of the variable at this other end. They said when y was 2, so let's call this y1, x1 was 1. So this is x1. So when y2 was 6, x2 was 4. Alright, so we are going to solve with this now. 2 equal k bracket 1 square plus, this is k1, k2 over the root of 1. Now this is going to give us 2 equal to k1 plus k2. Let us call this equation 1. Okay, when y2 was 6, x2 was 4. So we are going to have that 6 equal to k1 4 square plus k2 over the root of 4. Now this is going to be equal to 6 equal to 16k plus k over 2. So let's multiply through by 2. So if we multiply through by 2, we are going to have 12 equal to 32. So this is k1 and this is k2. Don't forget that. 32 k1 plus k2. This is what we are going to have. And let's call this equation 2. Now, we now have two equations. This second equation and the first equation is 2 equal to k1 plus k2. Alright, so let's substitute equation 1 from 2. So this is going to give us 12 minus 2. We have 10 equal to 31k. So k1 and the others are going to be 0. So if we have this, we can divide both sides by 31. So k1 is going to be equal to 10 over 31. Okay, so these are k1. So from equation 1, we can substitute k1 and then we'll be able to get our k2. So we have 2 equal to the k1 is 10 over 31 plus k2. So let's multiply through by 31. If we do so, we are going to have 62 equal to 10 plus 31 k2. Now, let's take this 10 to this other side. And we're going to have 62 minus 10 equal to 31 k2. So this will become 52 equal 31 k2. So we can divide both sides by 31 and then k2 will be equal to 52 over 31. From this, we have that our k1 is this and our k2 is this. But the question says that we should write down the expression of y. So it is the expression they want to know. And already we know that the variation is y equal to k1 x squared plus k over the root of x. So we are going to substitute k since we know what k is now. So this is k2. So we are going to have that y equal to k1 is 10 over 31 x squared plus k2 is 2 over 31 divide by the root of x. Now, this can also be given as y equal to 10 over 31 x squared plus 52 over 31 divide by the root of x. Okay, so we then have y equal to 10 over 31 x squared plus 52 over 31. Now for us to convert this division sign to multiplication, we are going to invert the root of x. We're going to have x 1 over the root of x. So therefore the expression y is going to be given as 10 over 31 x squared plus 52 over 31 root x. So this is what we have as our answer. Alright, so we have come to the end of the class. Please do not forget to subscribe as we are going to solve more questions and post. So when we post new videos and questions in this course, you'll be able to get the notification. Bye for now.